This is Unit 6, Lesson 7, Slope-Intercept Equations, Day 2. Here's a coordinate plane, and we have had some experience now graphing some lines. And so here's a line, blue one, that we are showing here, and we'd like to describe, if we could to someone else, say how tilted it is, how slanted that line is. Well, so we could say it's kind of slanted over to the right. Hard to say exactly just how slanted, but what if we had another line, a purple line? Well, it might be easier to compare them. The purple line is slanted up much farther. It's tilted up higher. And then what if we had a magenta line? Oh, that's slanted in the other direction, but it's kind of lower. Well, all of those descriptions are okay, but they're not very accurate at all. They're not very precise as a way to describe the slantedness and the direction of a line on the coordinate plane. So we need to find a way to be precise and describe exactly what we mean to others. And so mathematicians have invented something called slope to do just that. So the slope of a line, okay, the slope is a way to describe how slanted and in what direction a line is on the coordinate plane. The slope of a line, instead of being described in words like I was doing fairly poorly, it's described by a number. Okay. So the slope is really the rate of change from one point to another on the line, from any one point to any other point on the line. We're going to talk a little bit more about that eventually. Okay, slope is expressed as a ratio. We talked about it being a number. It's actually a ratio comparing two values. And the numerator is going to be the difference between the y values of the ordered pairs of those 2 points. And the denominator is going to be the change in the x values of those ordered pairs. And we'll show you just what I mean by that in just a few minutes. All right. Slope is represented by the variable m. S was taken by something else, so the variable m represents our slope. Right. The y-intercept is a little bit more straightforward. That is a point, an ordered pair, where our line crosses or touches the y-axis. That is called the y-intercept. All right, to determine the slope from a graph. So, like I said, the slope is a ratio, and it represents two values in a ratio, and the top one being a comparison of the y values of the ordered pairs from one point to the next. And we talk about it as the change in y value, so we're really talking about the difference between those two y values. And in the denominator, we're talking about the difference between the x values in those points. Now, I like to think of it in a little different way. Really, as we're going from one point to the next on a line, or from any point to any other point, we're really trying to look at how far up or down did we have to go. And that distance is going to be in the numerator. And how far left or right did we go? And that's going to be in the denominator. So I like to think of slope as up or down, over, right or left. Some people refer to slope as rise over run, kind of as an easy way to remember it. People think of rising as going up or down and running as going left or right. All right, so let's take a look. This will make a little bit more sense once we go through it. So here's our blue line. We'd like to determine the slope. So the first thing you need to do is figure out what are some actual points on this line. So you need to look at the grid of our coordinate plane and see where grid marks are intersecting and where the blue line is going right through an intersection. So you want to go ahead and find some of those and actually color in the points so it's a little bit easier for you to see where there are points that we know have integer values. So go ahead and mark on your paper those points as indicated here, and then we can get started figuring out the slope. All right, we need to just pick randomly any 2 points on this line. So I'm going to select these two. And what we want to determine is how far up and how far over we need to go, up or down, and then over, left or right, to go from one point to the next. Now, we can't just measure the distance from the one point to the other diagonally because we can't tell exactly what that length is because the diagonal line doesn't have units on it, whereas the vertical and horizontal distances on our coordinate plane are correlating to the individual points of the coordinate plane. So we're going to measure first from one point to the next how far up we have to go. So you're going to see here that I'm counting. I would put my pencil on that first point and count 2 grid spaces up, and then I'm on the same horizontal row as that other point. So I'm going to write that down on the numerator of my slope fraction that I've gone up to. And we know that on the coordinate plane, going up is going in a positive direction, so I'm going to write +2 on the top of my fraction. And then from that same point, I'm going to travel then over to the other point, and in this case, it's to the right, 3 spaces, and so to the right on our coordinate plane is a positive direction, so I'm going to write right 3, and that's a positive 3. So I've gone up 2 and to the right 3. Now what I need to do is look at that fraction and simplify it, and it's already simplified, and positive over positive makes positive, so our slope is 2/3. So that number describes specifically how slanted our line is, a slope of 2/3. Now we're going to try it again, but this time we're going to pick 2 other points. So I'm going to pick these 2 points. I'm going to do the same process. So I'm going to first see how far up I have to go to get to the same level as that other point. So I've gone up 4, so that's up 4, that's 4 in the positive direction. So I've gone farther than last time, but then I also have to go farther across. So this time I've gone across 6. So that's to the right 6 spaces. To the right is positive, so that's positive 6. So I've got different numbers this time, but let's take a look. When we simplify 4/6, look, it comes out 2/3. So the slope is always going to be simplifying to the same exact value from any point to any other point anywhere on the line. Let's try one more time. What if I went first from this top point down to the one farther to the left? Well, let's give that one a try. Now, to travel first, I have to travel down this time. So I have to travel down 6 spots. So I know that down is a negative direction. I'm going to write -6. And then I'm going to have to travel to the left to get to the other one. And I have to go to the left 9. So I know that is also a negative direction. When I simplify -6 over -9, I get +2/3. So you see, anywhere from one point to the next on this blue line, the slope is going to be 2/3. Now the y-intercept is a little bit more straightforward because you're just looking for the point where it's crossing on the y-axis. That's the vertical axis. You see the line is crossing right there at the point 0, -1. So that's our y-intercept. And sometimes people write it just with the value of the y coordinate of the y of that point. So we could say the y-intercept is -1. All right, here are the points that you should have shown on that line. Make sure yours are the same as mine. Now we're going to compute our slope. I picked these 2 points. It doesn't matter which 2 you've selected. Once we simplify, we should all get the same value. So the first thing I'm going to do is count from one point to the next. I've gone up 3, so that's going to go in my numerator. And then I went to the right 1, so that's to the right 1. That's a +1. So when we simplify, we get a slope of 3/1, which simplifies to the whole number 3. So go ahead and express it as a whole number if it simplifies to that. To get our y-intercept, we want to look at the point where it's crossing on the y-axis. You can see this point right here is the point 0, 2, and so we can write it the y-intercept equals 2. All right, example 3, give that one a try. All right, example 3, here are the points that I've shown where it's hitting at the intersection on the grid. And I'm going to go from one point to the next. These are the 2 I've selected. You can see that I have to travel down 3. That's in a negative direction. So down 3 means a -3 in the numerator. And then I have to travel to the right. So that's 4 in the positive direction, a positive 4. So when I go to simplify negative 3 over positive 4, it comes out as a negative 3/4. The y-intercept of that line is right there. There's my y-intercept. That's the point 0, negative 3. So we can say the y-intercept is negative 3. That's it. That's it. Put your note sheet in your binder. I'll see you tomorrow.